Okay, I'm going to start Chapter 8, 8.1. Chapter 8 is called a transition. What they mean by that is we're going to look at a transition between the things that you guys have seen in beginning algebra and then the things that we're going to learn here now in intermediate algebra. The book will review some things from time to time covered in the beginning algebra part, and then it's going to extend those to new ideas here in the intermediate algebra part. 8.1 is all about linear equations and absolute value equations. So there's several times earlier in the book where they talk about linear equations, and so they're reintroducing that again. Definition: a linear equation is an equation of the form ax plus b equals 0, where a and b are real numbers. So I've got some examples here. We're going to solve some equations. Of course, when I solve an equation, I want x on one side and all the other numbers on the other side, right? So let's begin doing that now. Problem 1, I want to solve 9x plus 13 equal negative 14. All right, so if I subtract 13 from both sides, negative 14 minus 13 is negative 27. And then divide by 9, that way x is all alone, and we've got x equal negative 3 then is the solution to this equation. You're welcome to check your answers if you want. If you're comfortable with the algebra, there's no reason to be doing that though, okay? On occasion, sometimes later on, we will need to check our answers, but we don't really need to do that here if we're, like I said, if we're comfortable with the algebra part. Here's another example, okay? I want to solve for x. Now, before I do that, notice how in the definition, so in a linear equation is an equation that can be written in the form ax plus b equals 0. I'm not writing these equations in that form, okay? I could if I wanted to, we're not doing that, we're solving the equation, but the point is that we can still call these linear equations, okay? Let's take a look at part B, solve for x. So if I add 2x to both sides, for right here I'm adding 6x to both sides and then subtracting 5 from both sides. Negative 2x plus 6x is 4x on the right, and then I'm also subtracting 5 from both sides. 29 minus 5 is 24 on the left. Divide both sides by 4 now, that way x is all alone. And you'll have 6 equals x, or x equals 6, that's the same thing. Of course, we don't care what side x is on, just make sure that x is all alone. Here's another one, part C, solve for x. In part C, I'll need to use the distributive property twice. I'll need to distribute 4 into these two terms here on the left, and then the negative 1 into these two terms on the right. Make sure that you distribute into both the terms. I'll have students sometimes mess this up and they'll only distribute the number into the first term and not all of the terms. Don't do that. So let's distribute here. 4 times negative 2x is negative 8x. 4 times 1 is 4. And then over here, negative 1 times 2x is a minus 2x. Negative 1 times negative 3 is plus 3 at the end. Combine the like terms. 3 plus 6 is 9. And then the next thing, I'm going to add 2x to both sides and then subtract 4 from both sides. Negative 8x plus 2x is negative 6x on the left. And then I'm also subtracting 4 from both sides. 9 minus 4 is 5 on the right. Last thing, divide both sides by negative 6. And so x equals negative 5, 6 would be the answer on that. Now, when you're solving an equation, unless you're told otherwise, keep the answers in exact form, okay? Like there's no reason to be going to the calculator and giving some decimal approximation or something like that. Sometimes we will be doing that. We'll be using the calculator, but at the moment we don't need to be doing that, okay? We're looking for exact answers. Of course, simplified also. If the fraction simplifies, simplify it. Here's another example, okay? Part D, solve for x. And now in this problem I've got fractions, and the way to begin that would be to clear out the fractions. 20 is the smallest number that 4, 5, and 2, and 5 will go into evenly, and so it would make the most sense to begin the problem by multiplying both sides by 20. So I've done that, and Of course, I'll need to distribute here on the left. 20 times 3 fourths, well, 20 over 4 is 5, times 3 is 15. And then with the next term, 20 times 1/5 x, well, 20 divided by 5 is 4, so I'll have 4x there in the middle. And then minus 20 times, half of 20 is 10 there. On the right, 20 times 4/5 x, well, 20 divided by 5 is 4. 4 times 4x would be 16x then on the right. Combine the like terms, 15 minus 10 is 5. And then I'm going to subtract 4x from both sides. 16x minus 4x is 12x there on the right. Divide by 12, that way x is all alone, and we're getting x equal 5/12 then is the exact answer. Of course, another way to do this problem is that you could work with fractions. You know, it's not ideal to be doing that, but it's not like we had to get rid of the fractions. That would be recommended, you know, just in general, when you're working with fractions. Try to clear those out early on if possible. Here's another one. Okay, part E, solve for x. I'll need to distribute in this one. Distribute 6 into these two terms, and then 7 into these two terms. So 6 times 2x is 12x, minus 6 times 3 is negative 18. Over here, 7 times x is 7x, and then 7 times 4 is 28. Combine the like terms there. 12x minus 5x is 7x. If we subtract 7x from both sides, then those terms are gone, and that's going to leave you with negative 18 equal 28. Of course, negative 18 does not equal 28. That's false. But x was eliminated completely, and we ended up getting something that's false. What that means here is that this equation has no solutions to it. The empty set is this symbol here is a symbolic way to represent no solutions. You could also write no solutions, that's fine. We call this equation a contradiction. That's not really an important term that you have to know going forward. Your book doesn't use it a lot, but it does use that term here in the section. A contradiction is just simply an equation that has no solutions to it. Here's another one, part F. Okay, solve for x. Again, we'll need to distribute. So I've distributed 3, and then the negative 1, and then the 2 here. 9x plus 39 minus 8x plus 7 equals 2x plus 46 minus x. Okay, 9x minus 8x is x. 39 plus 7 is 46. 2x minus x is x, and then I've still got the 46. If I subtract x from both sides, then those terms are gone. And that's going to leave me with 46 equal 46, which is not news to me. I already know that 46 equal 46. Okay, but this is different from what we saw over here, because 46 equal 46, that's true, right? Over here I had something that's false. X was eliminated completely, and we ended up getting something that is true, okay? And therefore, all real numbers are going to be the solution to this equation, okay? Here's the symbolic way to represent all real numbers. We use a capital script R. I'll talk about some other ways to describe all real numbers later in the chapter here, but this equation, by the way, is called an identity. An identity just simply means that all real numbers are going to be solutions, okay? And for this problem, like, it's not going to matter what x is. You go through the procedure and you'll always have 46 equal 46, which is true. So x could be any number, it doesn't matter. Okay. Another kind of equation that we'll need to know how to solve is an absolute value equation. An absolute value equation is an equation that contains an absolute value expression. Let a be some positive number, so a is greater than 0, and u be an expression involving x. Then if you have the equation, the absolute value of u equal a, and you want to solve for x, what that means is that in order to lose the absolute value bars, you'll need to write two equations. One of them is going to be like the absolute value bars are not even there, and then the other is you want to throw a negative onto the right. Okay, be sure to drop the absolute value bars after applying the definition. You've now applied the definition to be able to do that. Also, sometimes we work with absolute value equations where there's absolute value bars showing on both sides. So if you have the absolute value of u equal the absolute value of a, that actually means the same thing. u equal a or u equal negative a. Bottom line is that when we plan to use the definition and get rid of the absolute value bars, we must write two equations down. Okay? The most common mistake that a student will make is that they'll only write one equation and not get the other one. Okay, don't do that. So here's some examples. I want to solve each equation for x. The first one, the absolute value of x equals 7. All right, so go right to the definition and write your two equations. Remove the absolute value notation. X equals 7 or x equal negative 7. Circle those, and they're both correct. Okay. Now, of course, anything coming out of the absolute value bars is never going to be a negative, right? I get a negative x value here. That's okay. The absolute value of negative 7 is 7. Okay, so I'd want to keep that number even though x is a negative. It'll happen on occasion where x is a negative. Okay, you're still going to keep that number because what x can be and what's coming out of the calculation are two different things. Okay, only reason why I mention that is because I do sometimes see students cross out a negative number saying, well, we can't have a negative with absolute value. Yeah, that's true. You can't have a negative coming out of the absolute value bars, but that's not what we're talking about. X is going into the absolute value expression, not coming out of the absolute value expression. Here's another example. Okay, solve for x. So first thing is to get rid of the absolute value bars. You'll write your two equations. One of them is going to be like they were not even there. The other one, just throw a negative onto the right. And now you're going to solve for x on each one of these. Subtract 5 and then divide by negative 3, and you'll have x equal negative 7/3. That's one answer. And then over here, subtract 5 and divide by negative 3. Negative over negative is positive. And so x equals 17/3, that'd be the other answer. Okay? And like what I was saying before, make sure that you're giving the answers in exact form. You don't need anything in decimal form or be doing anything with a calculator in this. Okay, here's some more examples. Part C, solve for x. So the first thing that you want to do is you want to get the absolute value expression all alone and on one side. Okay, if you got multipliers or adding numbers or stuff like that, go ahead and clear that out first so that the absolute value expression is all alone on one side. Here I'm going to add 5 to both sides. Then I'm going to apply the definition for removing these absolute value bars. So again, one equation is going to be like they're not even there. The other is going to be where I just throw a negative onto the right. With this one, and actually on both of them, you're going to subtract 2 now from both sides. 14 minus 2 is 12. Negative 14 minus 2 is negative 16. And so here's my two answers. Part D, solve for x. So yeah, again, we want to get the absolute value expression alone, which means in part D, I'll want to add 7 and divide by 2. 3 plus 7 is 10. 10 divided by 2 is 5. Okay, now apply the definition for removing the absolute value bars. So I've got my two equations written. One of them is going to be like they're not even there. The other is going to be where I throw a negative onto the right. Now I'm back on familiar ground, right? Because I don't have these absolute value bars in the calculation anymore. That's good. On both of these, you're going to have to subtract 8 and divide by 3. So over here, when I subtract 8 and then divide by 3, I'm getting x equal negative 1. Over here, when I subtract 8 and divide by 3, I'm getting x equal negative 13/3. Okay, here's another one. Solve for x. If we subtract 10 from both sides, then we've got negative 6 there on the right. Now in this problem, we can go right to the answer. It's no solutions. Okay, or the empty set is the symbolic way to represent no solutions. I mentioned that earlier. Anything coming out of the absolute value bars is never going to be a negative. Okay, so it's not going to matter what x is. X can be any number, it doesn't matter. Anything coming out of this calculation will never be a negative. So you will never have a positive equal negative 6. Okay, that will never happen. Because that never happens, no solutions would be the answer to that one. Okay, that to me is just to think about it and go right to the answer type deal. I think there's a couple of those in the book. Watch out for those, okay? Anytime you got a negative on one side of an absolute value equation and the absolute value expression is all 1 on the other side, no solutions, okay? You can't have a positive equal a negative. That's not true. Here's one more, okay? Now, in this problem, I've got absolute value bars showing on both sides. That doesn't matter, okay? The definition is the same as if I had absolute value bars only on one side. Okay, so I'm still going to be writing my two equations like I've been doing in all before in all these other problems. The first equation is going to be like the absolute value bars are not even there. The other one you'll want to throw a negative onto the right. Now I would also add that in this problem, when you throw a negative onto the right, be sure to add parentheses. Since you want negative the whole thing on the right, you'll want to distribute that negative into the two terms there. Okay, and so that's what I've done here on this next step. Of course, remove the absolute value notation. Okay, and now we're back on familiar ground. So if I solve this guy here for x, add 3 and subtract x, 4x minus x is 3x, add 3, 6 plus 3 is 9, and then divide by 3, you get x equal 3 is one answer. And then over here, like I said, I'm going to distribute the negative into these two terms. I've done that. And then add x to both sides, and then add 3 to both sides. 4x plus x is 5x. And I'm also adding 3 to both sides. Negative 6 plus 3 is negative 5 on the right. Divide by 5, and so x equal negative 3/5 would be the other answer that we need. Okay. Typically, when you solve an absolute value equation, you're going to have two answers. That should make total sense because you get two equations when you apply the definition for removing the absolute value bars. Okay, so keep that in mind when you're working with this stuff. That's it for section 8.1. The homework problems in the book that you'll want to look at are on page 617. Do the odd numbered problems listed here for me.